Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and welcome to another one of my screencasts where I use the programming language R to analyze a dataset that I've never seen before. So as usual, these datasets are taken from Tidy Tuesday, a great weekly project run by the R for Data Science online learning community. And this week we're going to be taking a look at TV's golden age. So I'm a big fan of TV, so I'm really excited about this. All right, let's take a look. It's The Economist. TV ratings via IMDb from 1990 to 2018. Oh, this is going to be great. So, as usual, what I do here is open the CSV, go into the raw version, and grab this URL. So I can do library tidyverse, read CSV. I could say Economist TV. I'll just call it TV ratings, this data set. And I'll say Golden Age TV. All right, and now I've got my data set. Let's see what columns we have here. We have it's one row per season per show, it looks like. So if I look, what shows have the most seasons? Law & Order, no surprise there. CSI, it's a long-running show for sure. Okay, so we have, we're missing some things. We don't see The Simpsons. It must say just shows that have started since 1990. I guess that's what it means by 1990 to 2018. Okay, so it has per season per show. So if I take, what's a show that I enjoy? I don't know, I like The Wire. We have 5 seasons, pretty high ratings. What's a show that would have multiple seasons? I don't know. Let's see what else. What other shows I like? I like The West Wing. Right, also pretty high ratings. Okay. And what about Law and Order? I wonder, has it been getting worse over time? This isn't the kind of thing I do when I open up a Let me correct how I spell that. Law ampersand order. This is what I do when I open up a data set that I'm interested in, is I start by looking at a few particular, answering a few very specific questions. So Law & Order, it suggests the best season was probably about the 6th season, and it's been pretty consistent over time. So it's even hard to say that it had a best season. Okay, The West Wing got worse in its later seasons, in my opinion, but it's so interesting. It doesn't show up in this data. The 5th was the weakest. That's pretty widely agreed. Okay, actually, this fits sort of my view of the West Wing's seasons. How about The Wire? I would have said the 5th season was the weakest. The Wire. Okay, I wouldn't agree with all of these. How about Buffy the Vampire Slayer? That's a show I'm a fan of, where I have a strong opinion on its footprint across seasons. Yeah, so it peaked in the 3rd season. That's a pretty, that would be my opinion too. I probably would rate the 7th season, 6th and 7th seasons a little lower. Okay, so this is, all right, I wonder what share is. Let's find out based on the specs. Is that, well, it's not telling, oh wait, share. It's really not telling me much. I'm guessing it's supposed to be visitors in millions. Or no, it may well be a percent. It couldn't be a percentage. I would be even surprised if it were millions. That would suggest, no, it couldn't be. If that was just far more people were watching Buffy the Vampire Slayer than Law and Order, which is definitely not accurate. I wonder what share is. Okay, if I look at, let me see. IMDb. If I just search for share, no, that's not going to do it. I just wonder if I go The Economist, GitHub. I really don't want to analyze it until I know what it means. Let's see. November 24th article. Well, I can't find anything right now. Maybe we'll stumble on something later. Till then, we'll have to just use ratings. Okay. All right, so let's start answering some questions. I'm going to start with, do most shows get better or worse over time? I'm going to want to look at the average footprint. of a show with multiple seasons. So I could start with, let's see, how many of each season do we have? If I look at season number, looks like many shows have just one season, and they start to decline after that. I wonder if there's a pattern. Like if I said season number N, line, not a pattern, I mean really, what is like a turning point? Well, it seems pretty clear we can't really look beyond 10 seasons. In fact, it's probably hard to look beyond 7. Okay, so I'm going to start with by asking the question, what's a typical pattern of shows for their first 7 seasons? So I'm going to leave this in, but I'm going to say group by season number, summarize average rating is mean of average AV rating. I guess I'll drop off the G to be consistent. So what I can say it now is, do shows get better or worse? Well, here's a line of the typical footprint. So one thing to note here is we really don't want to include, as I just mentioned, we really don't want to look at seasons 10 and beyond. I'm also wondering, have some shows been skipping so they have later season numbers? This is a very odd, over here is a very odd pattern. No matter what, I'm going to want to say filter season number less than, let's say, first 7 seasons. All right, so this is a typical, looks like is just the path. This is very interesting. This suggests that the average show 5th season is far higher than the average 1st season. But we have a selection bias here. The kinds of shows that only make it to 1 season are probably going to be the relatively low-rated shows that people have low opinions on. So we probably don't want to just say, and that would explain why there's such a big jump when you get to the 2nd season. The kind of show that lasts to a 5th season, even if that season show is not as good as the earlier ones, maybe it's still a pretty maybe it's still like a relatively good season. So let's look at this a bit differently. I'm going to say you must have at least 5 seasons. And this reminds me, why I'm really nervous about the fact that look at this. No show has more than 20 seasons, and yet we saw later seasons. So why is that? All right, so we have a show like Politsarov 110. We have these shows that appear to have these late seasons. I can ask this different way. I can say, how many shows are we missing seasons? If I group by title and I arrange by date, I can say add a season number is row number, and we'll get a new metric. We can say which row did it occur in. Aha, and now we can say that, for example, there's loads of shows here where, arrange by date, yeah. Where, look at Quantum Leap, title equals Quantum Leap. Oops. We only have seasons 2, 3, 4, 5. Okay. That's not that's going to be a data quality issue, because it looks like we have it from the first season, but we don't. What else? Looks like we're also missing some Full House. All right, so I was wrong that it was just shows that started since the 1990. I don't know why The Simpsons is missing, but yeah, it looks like it has some shows that started midway. Okay, given that, I am going to want to look only at new shows. So I could start with this. I could start by group by title, filter 1 in season number. This means you must have a first season to be included. Now I can try this again. And now I can ask, I'll ask this a bit differently. I'll say filter, where does season number not equal the position within your within that group? Okay, so we see, for example, Beverly Hills 90210. It has a okay, I'm actually gonna go back to the step where I'll say row number is this. Filter row number is not equal to season number. All right, and it looks like this should have been the 4th season, but instead it's the 6th. Okay, I'm going to say we've grouped. Now I'm going to filter. We must have every season of the show. Every season at least up till today. So I can say 1 must be in the season number, and the season number must always be equal to the row number. What are my warnings? Oh, I'm not sure what that is. That's a little interesting. Okay. So, all right. So I say title, season, title ID, season number, title, date, and now we must always have the full show. Okay, I feel better about this. So I'll call this TV ratings full show. All right. And now I'll ask TV ratings full show. Let's see, I'm still grouped by title. So I'll go ahead and say filter. You must have at least 5 seasons. All right, so these are 143 shows with at least 5 seasons. Now I'm going to filter for season number greater than 5. Excuse me. So now less than or equal to 5. And now I can ask the question about season numbers. I can say, summarize, what's the average rating? And what's, this should always be the same. Yeah, we have 143 observations of each. All right, so this is the average rating of shows across their first 5 seasons. That's incredibly steady. Okay, so this suggests there is not, at least in the first 5 seasons, for shows that have at least 5 seasons, there's not a general trend. That really surprises me. I would not have generally expected that. Let's find out if there's not a trend in the average. There could be a trend in the median. There could be a trend in the variance. So let me try, instead of, let me try grouping. Oh, let me try GG plotting. We'll put on the x-axis the season number, and on the y-axis the average rating. Okay, so there is a trend. There's a trend in the median. Could I have found that out? I'm double checking myself. Summarize median average rating. Yeah, a little bit. Okay. So this suggests the first season is on average a little bit worse. Actually, we saw that in the mean as well. The first season's a little bit worse. And then it's pretty steady. Handful of outliers. Okay. Shows that last this many seasons don't often have low ratings, at least not below like 7. So we've got to deal with the dynamic range of these observations too. Anyway, 7 looks like a really low rating. And do we have ones? No, that would be 9.5. That looks like it's as high as it goes. Okay. That's an interesting question. It's not as informative as I necessarily expected to be. I didn't ask them before. What are the best seasons of TV? Let's see if I agree. I'll say highest rated seasons of TV. We don't need the ones with the full show. I'm just going to start with the original data. And I can say arrange descending average rating. Looks like the first season of Parenthood. Is it a different Parenthood than I'm familiar with? I don't think the first season was 1990. All right, we have season 5 of Breaking Bad. That's definitely a great season. Season 6 of Game of Thrones. I don't know that I'd necessarily agree with that. All right, so there's some there's some surprises here. What are the worst seasons of TV? First season, I'm guessing this is Keeping Up with the Kardashians. Okay. What if I said across all the seasons? If I said group by the title, so I'm gonna replace this. I'm gonna say group by title, summarize, average rating is mean average rating, seasons equals n. And now I can say, let's see, arrange descending average rating. The highest show on average was the one season we include of Touched by an Angel. I don't know, it seems a little odd to me. Some of these are shows I like. Some of these are shows I don't like as much. Some of them are shows I'm not as familiar with. Okay. Let's look. Let's see. I wonder what the worst shows are. I hadn't really heard of Doubt. Keeping Up with the Kardashians has 2 seasons. It's low rated. Okay, so these are some views in terms of best and worst that, like I said, I wouldn't necessarily agree with. We could make a plot out of this, but which seasons shows have the most variation? I'm gonna call this by show because I'm doing an aggregation, and I'm gonna say standard deviation. What's the deviation of their ratings? It's going to be meaningless for shows with 1 season. That is NA. Not defined. If I arrange by descending SD, and let's take only shows with, I don't know, let's take only shows with at least 5 seasons that in the data set. So it looks like there's shows like Are You Afraid of the Dark? Not that I think I watched it sometimes when I was a kid. Friday Night Lights has a lot of variability. I've heard about Friday Night Lights that I've only seen the first season, but the second season is supposed to be really bad. That's probably why it has so much variability. Scrubs and Dexter, both shows I watched all the way through and had huge drop-offs near the end. So this is actually pretty interesting. I can say, let's take all of our seasons. I'm going to start just with, I'm going to start just with 2 shows. I'm going to say the 2 shows here that I'm most familiar with, Scrubs and Dexter. And I'm going to say what are their patterns in terms of season number, average rating. And I'll need to add color equals title. These are some shows that went down the tubes in roughly the last season. Remember that this is a measurement of fan opinion. So these are going to be like last seasons that are generally reviled by people, the kind of people that are rating shows on IMDb. One thing that's interesting to me here is that Scrubs had a last season where it gave up a lot of the cast, and it looks like that wasn't very popular with the with people reviewing it. Dexter had a very, in my opinion, terrible finale. Not a good final season. But it's so interesting that it has such a lower rating than anything else on the show. I'm gonna guess that Friday Night Lights is going to be a really bad second season. Again, that's a kind of notoriously bad second season. Fascinating to me. Oh, we don't have season 1 here. Okay, so in this data, we don't have Friday Night Lights season 1. That's very odd. Friday Night Lights, it says it has 5 seasons. No, it has all 5. I'm wrong. Probably for that, I'm adding in points here, and I'm going to scale X continuous. Breaks are 1 to 8. I'm going to add all the points. Yeah, it has season 1. For whatever reason, Friday Night Lights has a very low-rated first season. Really? I'm forced to look that up to spot check this. I kind of find it hard to believe. Where are these season ratings anyway? Maybe it's the average rating. I guess the average across this. I don't know exactly what it's measuring. Okay. Well, it has, I guess, a low-rated first season. Not sure what to do with that. Okay. All right, and then we can make a graph out of this. I've been picking a few shows that I'm interested in, but it might make sense to say, take your TV ratings, interjoin them with your by show, say by title, and then take the, nope, I forgot that won't work. I'll need to do top N before I do the join, so I'm doing this in the group. Say top N 6, take your top 6 standard deviations. Now I've got just those shows. I probably want to do that up here. I want to say top end 6 SD. Yeah, so most variable shows. So these are your most variable shows. I'm doing this up here because I need to do the filter first. All right. And I'm taking the most variable shows, and now I can graph all of them on the same plot. When I graph all these when I'm graphing 6, I probably don't want to use color. I probably want to use faceting. So I'm going to say, here are your 6 graphs in terms of footprints of highly variable shows. So there's some shows that have one incredibly low rated season. There's other shows that I'm gonna drop the breaks, let it pick its own breaks. Just don't love it being 2.5, 5.0, but I don't actually know I don't know a great way to specify the break width. I actually don't know how to do that in ggplot2. I wonder if this is the time to learn. You can say breaks. So you can take the limits and return breaks. I guess that's what I'm going to do. I'm going to say the limits. Does it take the maximum and the minimum, or does it take the... Well, let's find out. Seek lim 1 to lim 2. No. Maybe it takes both limit. What limits is it printing here? Haha. I'll need to, the limits right now are 0.5, each of them. So let's say round, let's say floor to ceiling. Ceiling. That looks better. And let's separate them by 2. So what am I doing here? I'm saying when you get a particular set of limits, I want only the even numbers to be highlighted. Okay, cool. So these are our series, our footprints of each series, and yeah, it's not making the most sense to me, especially things like Friday Night Lights that says which says the first season's the worst. But all right, that was at least one graph of particularly variable shows. I'm going to go back up to the top and say theme set, theme light, so that I can, and I'm going to do one more thing. I'm going to say theme legend position equals none. I don't want that legend. All right, that's it's a pretty interesting graph. Learning the patterns of shows over time that show a lot of variation. Someone really doesn't like the later seasons of Are You Afraid of the Dark? Okay. I'm going to get back to the kinds of questions that it looks like The Economist was asking. Has TV been getting better or worse over time? Let's start answering that. Let's take a look at all the ratings again. We've been looking mostly at season number, not a date. And I could be grouping by year instead. I could group by year of date. I'm going to need library lubridate to do that before. And I could answer questions over time. In particular, I could say average rating is the mean of these ratings. I could also say median rating equals the median of the average ratings. Always interested to see if that's a different pattern. Those look exactly the same. I wonder if I'm doing anything wrong. Is it just me, or are those exactly the same values? Maybe they're normalized within each year. That would be interesting, but I don't... Ooh, shoot. I know exactly what I did. Check this out. This is it's not a bug, it's a common mistake you can make, is I'm using this value here. So it's actually, the second value is actually summarizing this first one instead of the original data. Much better. Okay, that's what I was trying to do. Okay, so I could say, here's your average, here's your median. Okay, now I can answer and it never hurts to get a standard deviation. Okay, Before I look at that more, and I am going to look at that, I really should have looked at some histograms. I probably should have said, what's the distribution of, say, I could have added year to each of them. And I should have said, what's the distribution of average rating? First, what is it overall? So it looks like it's mostly normal with a skew of outliers. It makes a little bit of sense. One thing that worries me here is maybe the outliers over here have really low maybe they have a really low number of ratings, so we probably shouldn't pay too much attention to them. Looks like it's maybe it's for whatever reason it's very hard to get all the way up to a rating of 10. So we don't see a skew of things that accidentally get a rating of 10, but we have a long skew on the left side. So that suggests that mean is probably pretty reasonable. Median may also be a good pick. We could imagine things like trimmed mean, but probably not going to bother with that. I can try faceting this as well. I can say facet wrap this by year. I can get many histograms, and I'm curious. This isn't necessarily the way to look at changing distribution, but it's a way to check our distribution assumptions. Looks like most years, they are pretty normally distributed, and then plenty of years we have our skews out to the left. Looks like some years have more of these skewed values than others. All right, all those are good things to know. All right, I might start with median. I really like, I think I'll start with both mean and median. Making a graph of change in quality over time, but I'm going to trust median a little bit more. All right, so I'm going to say it's also always good to have observations whenever you're doing a summary to know how many rows. Like only 22 bits of season data are going in here in these early years, yet not tons of data. In fact, might be so little that I'll need to aggregate a little bit higher, but I'm not going to try that quite yet. All right, so what I can do is I could graph year, median rating, geom line. All right, it's a solid start. This is where the economist's conclusion for the title of the article probably showed up. The golden age of TV is real. We really see a big difference between 90s and 2000s. Starting around 2004, yeah, it looks like about 2004 was an early peak, and we have another peak showing up around 2013. I'm just thinking about the history of TV shows. Without looking at the data we've looked at, like this was where certainly some shows I liked, like Lost, was showing up around 2004. This was where, like, say, Breaking Bad was ending 2013 it's 2014, the year after. But yeah, you can see some ways that this could be pegged to the golden age of TV. That's pretty interesting. One problem with medians is that they I'm really wondering with the spikiness. I think it's not necessarily the problem is not necessarily that it's median. In fact, if I look at mean rating, not quite as spiky, something very different. But these dips make me worry for sure. Okay, not sure which to trust. I know that I probably shouldn't be having I probably should be binning it a little more coarsely rather than every year, because this early data didn't have enough. So instead of year date, I could say 2 times year date. I've used this trick before, divided by, this is like floored rounding, integer division, divided by 2, which will aggregate it in pairs of years. I actually kind of like this graph. And this was the mean rating. What would the median rating look like? Like that even more, but of course here I'm really kind of p-hacking the data to show what I want to, so we have to be pretty careful. Yeah, there are a few ways to aggregate this. An alternative way is not to do an aggregation. Instead, to plot all of them, which is going to be way too many points, but geom point, average rating. Plot all of them, but then add a geom smoothing line, which I'd rather use low-s than gam usually. Low-s is particular type of smoothing based on local regression. Well, that doesn't look very good. It's very hard to tell what the trend is. I'm not crazy about that. I could try one other thing, which is a box plot by year. We already tried box plot by, we could try box plot by pairs of years, see how that looks. Again, I'm hacking into the data a little bit, which is not a fantastic practice, where I'm slicing it up lots of ways to see what interpretations we can make. Average rating. Oops, whenever I do this, I need to say group equals year. So these are pairs of years. See, what happens here is the variation within each year depends on, so the variation within each year is a lot wider than the difference between years. So whatever the trend is, there's still lots of exceptions on either side. That's kind of what we were seeing in that earlier attempt to smooth everything. I wonder if new shows are getting worse. This is a slight tangent, but sometimes you have to be willing to take a tangent. What if I said filter season number is 1? There are 854 times that a show starts in this data set. And I wonder if those been changing in their quality. Not really. Not really? That's a very interesting conclusion. Here's how I'm going to try answering this. I've got our mean rating. I could also have mean, I feel bad doing mean, season 1, where I'll say mean of average rating for all the season 1s in this pair of years. And now if I take a look, what has happened to the mean of season 1? While the mean rating has generally been going up, the mean of season 1, it looks like hasn't been. And that's really meaningful because if our hypothesis is TV has been getting better, that we wouldn't expect that trend. We'd expect the new shows to keep being bad. Maybe what's happening isn't that TV is getting better, TV is getting older. So that would be an interesting hypothesis. That what if we're just getting to later and later seasons, and more of the shows that currently exist are healthier and healthier. That is, they're the kinds of shows that have been around for a long time and tend to get pretty good ratings on IMDb. All right, so that's a possibility. So while I'm aggregating by year, I'm going to try average season. So what's the average season number? So then we can examine, are season shows getting older? No. To the contrary. Shows are, let's see. To the contrary, the average season of a 1990 show was already by season 5, whereas later on, it's earlier on. Okay, my hypothesis to why this could be the case, that shows are getting younger, is both that it's likely that there are more and more shows that get canceled after one season, but also we might have a selection bias that old shows canceled after one season either aren't in IMDb or don't have enough ratings to be included. So that would explain this this trend. But it doesn't explain why we see shows getting better, show ratings getting better, but not season 1s. All right, so I'm going to, just to check, I'm going to mean season 1. Okay, I'm going to call this by year. This is our year aggregation. Okay, and I'm going to gather. I'm going to say everything besides year, and it doesn't hurt to have observations. I need to say metric value. Everything but year and observations. What I want to get is the, for every year I now have the mean rating and the median rating and the mean of season 1 next to each other. Why did I do that gas? Well, because it's pretty useful if I want to say color equals metric. I can actually graph all of these on the same graph. Okay, as soon as I say on the same graph, I realize it's not great to do on the same graph because these will be on different scales. So I can try faceting them instead by metric, free y. Now I can say, but I don't love that either. Maybe I just need to not look at average season or SD. Maybe I need to say, or that is say I should not look at mean at I should not look at season or SD. Gather everything but that, and maybe I should put them back on the same scale. All right. So this communicates what I've been saying earlier, which is if you look at either mean or the median, you see a general trend of improvement. But new shows have not been getting better over time, generally. Generally, it looks like the worst time for new shows was the late 90s, but it's not that great now either. So new shows are not getting better, are not necessarily getting higher rating. At least when I say new, I mean season ones of shows, wherever they occur. That's really interesting. If I say season ones of shows are not getting better, are season twos of shows getting better? So if I do by year, let's see. Doing it by year, I'd probably want to aggregate this slightly differently. I still want to group by year, but I also want to group by season number. And now I can summarize the average rating, take the mean, or I'll call it mean rating, within each season, within each year. I definitely just say season number less than. I'm not gonna get anything. Oh, I can say I want either 4 or the season number of 4, whichever is smaller. So we maximize it. It's like 4 plus. And now I can say plot year mean rating. And this is still pairs of years. I probably need to be groups of 5. I only have one chance to do that before I slice this data up too many ways, but I just realized there's going to be too few observations here. Observations is N. Okay. Yes, yeah, there's very few, even in the first 5 years, there's very few shows in season 2 or 3. I'll have to make do with it, but I'll say color equals factor of season number. Here it is. So the general story is that your season 1s haven't been getting better, but your seasons 2 and 3 have. Season 4, probably just maybe not enough data, or this is 4 plus really. I wonder how many observations were there? No, there were 38 observations. Well, in 1995, there were, I don't know why it took a dip in the late 90s, but, well, who knows? This is a general story of, and this is generally suggesting that season 1s aren't getting better, but the following seasons are. All right. So shows aren't let me see. That's really, that's a pretty notable conclusion here, because it's just not all about the golden age of television. It's about, you could say it's about TV getting better at canceling bad shows and keeping good shows. That's one way to interpret this data. I'm thinking about how we could best separate that hypothesis from others. I'm going to. Here we go. I'm going to tidy this graph up a little bit because it's a good enough graph. It's probably worth the effort. Season, and I'll say. Let me see. I should probably also say. All right. We have our. If else, I'm actually going to do this a little differently. I'm going to say if season number is greater than 4 plus, otherwise season number. Because I wanted to have that 4 plus. All right, 1, 2, 3, 4 plus. Okay, I can also say y is average rating 5 years. Each 5-year period. Okay, so that tells us some things about changing quality over time. I'm thinking about how to measure this survival. This question of if season 1 is good, do you get a season 2? I'm gonna start playing with that a little. show survival. So if season 1 is good, what's the probability they get a season 2? So, I'm going to start just with the first 2 seasons. I'm going to say TV ratings, filter season number, take only our first 2 seasons. And I'm going to add count. No, I don't want to. Let's see. I want to select just title. I'm going to turn this into a transmute so I can change the columns. Select the title, select the season number, select the average rating. But I'm going to do something else. I'm going to say season number is paste season with season number. So now I can say season 1 or season 2. Why am I doing that? Because now I can spread it to 2 columns. This is from the tidyr package. I can say, I should really be looking at title ID and title. But even now that I'm looking at title ID, I wonder why count title ID title so does Twin Peaks have multiple rows? Ratings, or let me add a season number. I'm doing it wrong. Okay, here are 2 cases where we're doubling up for some reason. Filter title ID. All right, it's about the reboot. The reboot had the same title and was counted as season number 1, but this is a Twin Peaks reboot. But it appears again. I'm guessing that's the cause of the other situation as well. To fix that, I'm actually going to say only count each title and season number the first time it appears. It's a minimal change, but it should remove those. And then I should be able to say spread season number average rating. Here we go. All right. Now I can only include ones. I can even add a 3rd column. Why not? I can only include ones that have a first season. If not, we can't look at this question of season 1 survival. So I can say not is NA season 1. Good. And now I can ask the question, does the quality of your first season affect the probability that you'll get a second season? I can also, it occurs to me, only do this for dates before a certain point. So I could say group by title, mutate, first date is min of date, and include that in. Because I just realized I don't want to include, is this including any shows that just started? Yes. So these couldn't have had later seasons. So I'm going to go ahead, and we're going to want to know this year anyway in some of the other analyses that we need to run off this data. So I'm going to say of shows that have a first season, and they have to be, let's say have to be before 2016. Let's start with that. I guess that before 2017 they'd have had time for 3 seasons. I don't want to take any risk. I'll say before. I don't want to mess the data. I'm just going to say before 2017. I wonder. Arrange descending date. Do these shows have additional seasons? Did MacGyver? Didn't Lethal Weapon? I really don't know a lot about these things. Certainly could. No, yeah, it had season 3. Maybe it just wasn't in the data set. Okay, so that's another problem is that not being renewed. And This Is Us definitely had multiple seasons, and it would shock me if the later ones aren't in the data set. So I'm going to take one look at that. Say title ID is. We had. All right, so I did something wrong. Oh. How did What did I do? Let's see. Why did this spread? Oops. Group by title. Oh. Oh. Oh, okay. I unfortunately kept the wrong, date, S1, date, first season, I'm going to call it. Yeah, the problem was that I was keeping too much data. Alright, this is better. Lethal Weapon got seasons 2 and 3. Okay. I'm going to stick with this data set. Okay. Now I've got 685 shows that had a first season before 2017. And I want to ask a question. Does the quality of the first season affect the probability they'll get a next season? I can answer that with a statistical test, specifically logistic regression. Logistic regression is good when you have a binary output, true or false. In this case, I do. I want to know, is NA season 2, not is NA season 2, so had a second season explained by the quality of season 1 based on the first 3 seasons. Oops. Season 2. There it is. I'm going to put this through the Broom Packages Tidy. It makes it pretty easy to take a quick glance at the output. Okay. What this is showing is that, yes, shows with better season 1s tended to have, were more likely to get a season 2. So I could similarly say, if you look at season 3, does the probability of a season 3 depend on seasons 1 and 2? And it looks like, I'm actually going to use summary instead of tidy. Why am I doing that? Because I also am kind of interested in things like adjusted R squared, or AIC. Does the probability of a season 3 depend on seasons 1 and 2? Well, yes. Mostly on season 1. Oh, because you're not conditional on whether you have season 2 or not. I don't like this. That's too much thinking. I'm going to start just with 2 seasons. Okay, so we'd want to say. So now we can suggest that yes, whether you get a second season, show gets a second season, depends on the ratings of the first season. All right. It looks like it doesn't depend on it a whole lot. Why do I say that? Because this estimate 0.2 is multiplied by your rating. So a change in rating from the first season of all the way from 1 to 2, that's a pretty dramatic change. I'm sorry, from 7 to 8, that's a pretty dramatic change based on the ranges we were looking at. But it would have a 0.2 impact on the log odds ratio. It's hard to interpret exactly what that means, so let's actually aggregate this slightly differently. I'm going to ask, we've got our first 3 seasons. What's the distribution of season 1 ratings? Looks like it's mostly in between 7 and 9. Okay, so I'm going to, I need to think about how to group it. I'm going to n-tile it. That n-tile is a dplyr function that divides this into a particular number of bins. So I'm going to say n-tile of season 1 into 5 bins. Why doesn't it have any labels? Wish it had labels. Well, it doesn't have labels. It divides into 5 bins. What do I mean by 5 bins? I mean that if you counted them, they'd each have an equal number. And I'm going to summarize it into your had second season is mean of not is NA season 2. I'm going to say equals. So now we say, what's the probability that you had a second season given each of these ratings? Now that I see it, I know that it's a mistake to use n-tile. I should be using cut. I really want to have descriptive names. So I'm going to say 0 to 7 to 7.5 to 8 to 8.5 to 10. Dividing into 5 bins. And I can also include observations is N. Season 1 not found. Season 1, oh, right. Season 1 bin. And not a histogram, a line. I need to... And group equals 1. This is taking my time to make this graph. Okay. That actually is more dramatic than I had originally interpreted it. What this is suggesting, this is showing within particular bins, like if you have less than 7 to 7.5, what each, the probability of getting a second season. So it looks like scale y continuous labels equals percent. The kinds of shows that had only, that had below a 7 in their original, yeah, this is a pretty good graph for communicating this. The shows that had a bad first season tended not to get a second season. And then they go up, and then they start, looks like it kind of starts leveling off. So we got a significant trend when we did the statistical test. We can definitely tell the difference between shows that got 7.5 to 8, 8 to 8.5, and then above 8.5. You're still never certain, you're never guaranteed a second season. Those, I guess, are your one-season wonders. Like Firefly, that would be my example of a great show, lasted one season, I'm sure has a high rating. Can I say it? Let's find out. Yep, 8.67, but didn't get a second season. Okay, it's a great science fiction show, highly recommended. All right. Now let's take a look at, I want to know, has this been changing? Have, for example, TV executives been cracking down more on quality? So that's kind of the story that I'm approaching here, is I want to answer that question of has it become harder for bad shows to get a second season? The way I can do that is, let's look at the distribution of time across just these shows that we have a first season for. Most of our shows are relatively recent. I wonder then, I can let me look back at some of those graphs in terms of change over time. Yeah, where was this golden age? It was probably around 2004, 2000, this is 2002 or so. I'm going to add in geom points so I can distinguish the individuals. No, I was misinterpreting before. Oh, this is pairs of year. Yeah, I'd forgotten that entirely. 2002 to 2004, this is where we see a real shift in terms of quality. What if it's not a shift in quality? What if it's a shift in being able to get renewed for a second, the discrimination in terms of being renewed for a second season? It's a complicated idea, but it's like, what if a bad season show could get renewed here, but a bad season 1 could get renewed here, but not here? I'm going to use 2000 as a cut point, just because it's natural. I don't want to look like I'm picking too artificial a cut point in 2002, but we do see 2002 as the real change. Okay, the way that I'm going to try looking at this, I'm going to try it two ways. I'm going to try a statistical approach, but first I'm going to look at this curve. That's this discrimination of the effect of season 1 bin on the on whether you have a second season, and ask, does that differ if I don't just group by the season 1 bin, but I also group by before 2000? I'll call this time bin, and I say if else date less than the start of 2000, before 2000, after 2000. And I ask myself, time bin, color equals time bin. I don't think I need this line anymore. It's not date, it's date first season. And I do need group equals time bin. Otherwise, I won't know to connect the points. Aha. Okay. What this is showing is that it suggests that, yeah, a lot of the discriminatory power does come from the after 2000 range of data. It's a little hard to tell because we don't have absolutely amazing data. We don't have tons of data from the 90s. I feel bad. If I try 2005, will you forgive me for p-hacking a tiny bit? It's similar data, so I don't feel so bad about it. I'm gonna switch it back to 2000 and just, it doesn't matter what I write here. It matters what I put here. Yeah, it's kind of similar wherever so I think it, what I'm trying to see is like, I'm seeing this. Yeah, our discriminatory power changes a lot. It's like here, in fact, if you had between a 7 and an 8, you were more likely to get a second season than shows that had had an 8 or above. So that's really this fits very, very much with my hypothesis that based on the season 1's not getting better, that a lot of what's happening is that shows that last longer tend to those that have better ratings on IMDb tend to last longer. It's almost as if the tastes of executives are becoming more in line with tastes of Netflix raters. So that's really, really interesting. I said that I would test this in a statistical way. So let me show how we do that. We're using an interaction term. Here we go. So right now, I'm looking at does whether you have a season 1 affect whether you get a season 2? But I'm going to add in an extra step here. I'm going to add year. I don't want to use date as a term. It's a little. I don't want to use date as a regressor because then it uses days. That makes the intercept strange. I'm not crazy about it. I'm going to say season and year. Does that change the probability that you have a second, data equals dot? I've been forgetting to do, I said I was doing logistic regression, but wow, I completely forgot to say family equals binomial. The data is still very similar. Oh, wow, that changes completely my coefficient. All right, I made a mistake earlier. I said the coefficient of 0.2 is not very large because it's all about the effect on the log odds ratio, but that wasn't true. I was actually doing what they call the linear probability model. I was actually I was fitting binary data as the prediction from linear regression. So when I try log odds, this makes a little more sense. That every change, would be a full log odds ratio change in the It's a little hard to interpret. I'm not gonna try and put it into words, both because it would be confusing and I might get it wrong. But it's a larger coefficient for a logistic regression. All right, so I've added another term for year. Have shows become more or less likely to get a second season over time? And the answer is no. We don't see a significant trend there. We don't see a significant trend of over time shows have gotten more likely to get a second season. But here's what I bet you we will see. We're going to try season 1 interacting with year. So I'm actually going to place this. This will allow an interaction term of season 1 and year. Aha. Now we see that that over time shows. This suggests that over time shows have become less likely to be renewed. But while this happens, I'm looking at this. Okay, so this is suggesting that shows are less likely to be renewed over time, but there's an interaction term as well. So I'm trying to think of how to plot this. The mental image you'd have would be one where your probability of here it's wow, the rating has a huge negative. How did that happen? I guess it's a little hard to interpret these coefficients. The best way to interpret coefficients in a case like this is actually to use augment. So this is also from the Broom package. And I'm going to add had second season equals not is NA season 2. Makes the augment a little bit. Okay, so I say had second season based on all these probabilities. And then I can actually say, what was the probability a good show got renewed versus a bad show getting renewed? And I can use that with new data. So I can actually say new data is, I'm going to check out the crossing function from tidyr. I'm going to say whether you had I'm going to say year goes from 1990 to 2018. And had second, and average rating, season 1, that is the average rating of season 1, is going to range from 6 to 10, 9.5, I think it's the highest, by 0.5s. Nope, that's probably too many points. 6 to 9. This is our new data. This is what I'm going to be putting into the augment, because I'm going to say new data equals new data. Now I've got an augmented version where we have in this year and I need to say type predict equals response to give probabilities. So I can say what's the probability of a show with this rating being renewed in a particular year. And now I can make a graph. I can say, what's the probability of color equals factor season 1. Once I make it may be a little mysterious what I'm doing, but once I make the graph, it'll become clearer. Okay. Yeah, this shows the interaction term that's being fit. So what it's showing is the probability that a show would be renewed in 1990 was about 50-50. And it was very similar for good shows and bad shows. But over time, those have diverged. Today, or not today, but back in 2016, the probability of a show with a rating of 6 being renewed would be very low. And the probability of a show with a rating of 9 being renewed is very high. So I can say labels is percent format. Scales percent format. So this is my new interaction term model. So the conclusion would be shows let's see, probability of getting season 2 has become more dependent on ratings of season 1. That's a kind of a verbose title, but it does get the idea across. I can say season 1 rating, and then y would be predicted probability. This is what that interaction term was suggesting. Okay. Now there's one more. There's one thing here, which is that I'm treating these as linear. In truth, there could easily be a nonlinear relationship. I've shown splines in at least one session before. I'm going to end just by saying we could add predicted probability of getting season 2, and then year show premiered. I could add a natural cubic spline basis to year. Trends are rarely perfectly linear with regard to year. Probably not linear with regard to rating either, but this would suggest there's like this would get this totally wacky shape where it tries to represent this curve where it says, oh, in fact, a show with rating 9 would go up and then come back down. I don't know. Does adding a third one change anything? I don't really know. Maybe I shouldn't add more and more variables. Maybe I should have just kept it with year. very interesting to me that it all converges. Maybe it has to do with that fact that in our latest data, like 2016 level data, shows could still have gotten a season 2 that just hasn't aired yet. Or, I'm not sure, because the fact they're all converging here. I'm not going to overinterpret this. I'm going to keep this as our final version. This is just an interpretation of a statistical model that we did find to be significant. So we did statistically significant. So we did say, here's our model. And we see significant terms for year and for season 1 for the interaction term. So we see the predicted probability of getting a season 2 has become more dependent on ratings of season 1. So that could be is the explanation that I would suggest just from this preliminary analysis. That's the interpretation I would make of the fact that television ratings in general have been getting better, but wrong graph. Television ratings in general have been getting better, and yet the average season 1 has not. Okay, so that was a bit of a dive into this TV, the data set on the golden age of TV based on IMDb ratings. It's certainly loads of fun to take a look at television data. Like I said, there's certain ratings here that I'm a little bit skeptical of. I said I don't always agree with its ratings around seasons, but it's certainly part of the fun of working with this data set and understanding what IMDb has to show us. All right. Well, I had a great time, and I'll see you next week.